So we're going to build on this idea. We were asked to be bold at this Congress, come up with bold and defensible ideas, and now we're going to have a series of perspectives on this idea from various people from around the planet. And we're going to start with Dr. Alienor Chauvenet. She actually worked on this idea at ZSL and now is at the University of Queensland at the Centre for Excellence in Environmental Decisions.
Good afternoon, everybody. Unfortunately, I don't think I'm going to be able to match Harvey's enthusiasm, but I'm French, so you'll have to forgive me. I'm going to start with a brief overview about biodiversity, and then I'm going to present to you a case study, which is a new idea about how to designate protected areas. So you feel free to raise your hand if you've never heard any of the statements on this slide, but the world's biodiversity is declining at an alarming rate, and we all know that protected areas are a cornerstone of biodiversity conservation. And throughout this Congress, I've heard the figure that between 15 and 16% of terrestrial Earth is currently protected. And if you consider only the IUCN protected areas, there are thousands of them of various sizes. They go from really tiny to quite big. And some of them are strictly no use, where there should be no human impact at all, and some of them are multiple use. And we've seen some great success stories of international cooperation, such as the transboundary conservation areas, and some innovative thinking in land management, such as the mega conservation network concept. And people are continuously thinking about how to prioritize biodiversity. Where should we invest our money and where should we put our parks? Here are a few examples. Some of them are not taxa specific. I've put up the Global 200 ecoregions from WWF and the biodiversity hotspots for Conservation International. And some of them are taxa specific. That's bird life, important bird areas and endemic bird areas. As you can see, there is some marine areas highlighted here, but it's mostly terrestrial. So we all know that we need more PAs, but also we need better PAs. We need better managed, but also better chosen protected areas. And the question is, should we expand the protected area network with current approach, or should we try to find another way, a better way to identify area we should protect? And I've seen lots of talks at this Congress that seems to agree with the second statement. We need a better approach to selecting protected areas. Like I've said, many are quite small. In fact, out of the IUCN protected areas, more than 70% of them are smaller than 5 square kilometers. I think you'll agree that it's quite small and it's not really optimal for protecting biodiversity. And we need an explicit framework for ecological protection and good land use management. And we also need to be thinking about cost efficiency, about how we're going to invest our money, because resources are limited. So let me introduce you now to the conservation landscape concept. Sorry. So how we define conservation landscapes. They are a continuous area to conserve biodiversity and help large ecological processes. Very importantly, they should be large enough to sustain viable populations of the widest ranging terrestrial species, and they should be designated through a process that seeks to protect conservation landscapes from anthropogenic threats. And how you go about identifying such areas. First, we need to think about the minimum size requirement. So to do that, we looked at 4 species, which are the widest ranging species in key terrestrial biomes. That's the tiger in tropical forest, the wolf in boreal forest, the cheetah in the desert, and the wild dog in savanna. And we did a population viability analysis to find out what the minimum viable population size of each species in those biomes is. And then we related it to the known density in those biomes to find how much area each species need. And on average, the minimum area needed of continuous protected land is 2,700 square kilometers. So that's quite a big departure from 5 square kilometers that I've mentioned before. And the next step, once you know how big your area have to be, is to find where to put them. And this is done through a cost-benefit approach, where we try to maximize biodiversity conservation while minimizing the cost of establishing conservation landscapes. In order to maximize biodiversity, we look at species richness, so very simple measures. We're looking at bird, mammal, and amphibian species at the global scale, and then we look at the cost of establishing conservation landscapes. I think you might agree that it's quite a hard measure to find, but we use human footprint as a proxy. Human footprint is an index that is based on 9 variables. They include human density, road density, and some land cover variables. We apply this method to a case study in East Africa, in Uganda, Kenya, Tanzania, and Zambia. And we divided those 4 countries into grid cells. And for each of those grid cells, we looked at the total number of bird, mammal, and amphibian species. And we multiplied that by the total number of threatened mammal, bird, and amphibian species. What this did is identify grid cells that are not only rich in biodiversity, but also rich in threatened biodiversity, because the goal is conservation. And then, as I said, we've indexed the cost of conservation through the human footprint. And so for each grid cell, you get this benefit value based on species richness, and this cost value, you divide benefit by cost, and you get the benefit to cost ratio of every grid cell in order to answer the question, where would those conservation landscape maximize the biodiversity outcome while minimizing the cost? This is what 17% of East Africa look like if you... So once we had those benefit to cost ratio for each grid cell, we aggregated those cells that were adjacent to each other, and then we discarded areas that were smaller than 2,700 square kilometer, and that still leaves about 20 conservation landscapes in East Africa. I mean, there's quite a clear pattern here. Mostly the eastern side seems to be favored. There's nothing in Uganda. I've also plotted here the IUCN protected areas that are greater than 2,700 square kilometer on the map, because there are many of those, they're not all small. And as you can see, some of them match with the conservation landscapes, but many don't. I've also plotted what 50% of East Africa looks like. And obviously 50% is a lot of land, that's quite huge, but you can still see this east side being favored for conservation landscapes. And there's a big void here. Obviously there's also a big body of water right in the middle of this, so this is not unexpected. But still, Kenya and Zambia and quite a bit of Tanzania seems to be favored in terms of maximizing biodiversity while minimizing the cost of protected areas. In conclusion, I think we've shown that most current protected areas tend to be too small to protect the widest ranging species, the top predators. And we know that those species have been shown to be important for lower trophic species and also ecosystem functioning. And we've shown that their location does not seem to be always matching where you would maximize biodiversity benefit while minimizing the cost of protecting it. And we've tried to provide an idea about a new quantitative framework to address these problems. Thank you.